In this graph, they tell you that log 9y and log 4x have a linear equation, a relation like this. And then they tell you directly the slope is equal to negative 1 over 3. And very important, they tell you the intercept of the horizontal axis. They are talking about horizontal axis intercept. It's talking about this point. So this is 0, 3, 0. And then we are going to express the relation between x and y. You can write down the relation between the input and output by using this. If you do not feel comfortable, then you just consider there is another plane. The axis is x and y with the same slope and also the same intercept here. Beware that you should not write this in your exam paper. It's because this is not exactly correct. Or you may use UV to represent the asset, but you shouldn't use XY here. But anyway, we more get used to it. So for any XY point, general point, to form a straight line, slope is equal to slope. So we are going to write y compared with 0, x compared with 3 should yield negative 1 over 3. We know that y is equal to negative 1 over 3x and then plus 1. So that's our graph. And then in this exercise, we just change every y to log 8y, every x to log 4x. So we can write down log 8y minus 0 over log 4x minus 3 should equal to negative 1 over 3. The graph implicitly tell you that they have this relation. The axis have this relation, which is exactly the same as here. You just change y to this axis, you just change x to this axis. Don't forget this is wrong, so don't write that down. Now we can continue. Log 8y is equal to negative 1 over 3 times of log 4x and then plus 1. One of the difficulties is they have the different base, so we change it to the standard log, that means the base with 10, by using the formula. It's equal to log y divided by log 8. Basically, there is some simpler method, but this is more general to handle many different cases. We already know 4 and 8 are both able to express in terms of 2. So we just change it. Log y divided by log 2 power 3. Or immediately, you may just directly write down 3 times log 2. Is equal to negative 1 over 3. Log x divided by 2 log 2. Plus 1. Tidy up a little bit. We have log y divided by 3 log 2. We have negative log x divided by 6 log 2 plus 1. And everyone know that I hate fractions, so I should multiply LCM on both sides to ensure that there will be no fraction. Both sides times 6 log 2 is good enough. Therefore, in left hand side, log 2 divided by log 2, 6 divided by 3, 2 is left, so it's become 2 times of log y. Right hand side, 6 log 2 divided by 6 log 2 give you 1, so only negative log x is left. And don't forget, in the next term, we have to multiply 6 log 2. Now, I standardize all the log into the standard log, that means base 10. And then we just need to put everything inside log, then we can write down the relation between x and y. So we have log y power of 2, log x power of negative 1, and also log 2 power of 6. I have intention to put all the things inside log, and finally, two terms, I can combine them and form log 2 power of 6 times x power of negative 1. Left hand side unchanged. I successfully put all the things inside log, so afterward we just need to compare what inside. Y power of 2 is equal to 2 power of 6 x power of negative 1. To finalize our answer, we need to express y in this format but not y squared. So what I have to do next is to take square root. Y is equal to square root 2 power 6 x power negative 1, or y is equal to negative square root 2 power 6 x power negative 1. But however, what inside log it must be positive value, otherwise it is undefined. So y, the inputs can't be negative, so this is rejected. And our answer is y equal to 2 power 3, which means 8, and then x power of negative 1 over 2. So we successfully answer y in this format, where a is 8 and k is negative 1 over 2. In general, this kind of question is typical. By the relation in this straight line, you know this relation. And then we find out that they have different base, so I try to standardize it, and then both sides times same things to make sure that there is no fraction and all using the same log base. Now finally we just put everything inside log and then remove it. Tidy up a little bit, we get the final answer.